Here we shall see new topic, that is finding maxima and minima of the function of three variables using method of Lagrange multipliers. Let f of x comma y comma z be a function of three independent variables x, y, z, where x, y, z are connected by the relation pi of x comma y comma z that equals to 0. So this is a condition, and where x, y, z are the connected by this relation, and these are the independent variables of the function f of x, y, and z. So this type of problem solved by using Lagrange's method of undetermined multipliers. We'll see how this method works. Working rule: to find the extremum for the function f of x comma y comma z subject to the condition pi of x comma y comma z equals to 0. Here we find the extremum, nothing but maxima and minima of the given function. In this step 1 comes as form a Lagrange's function, that is capital F is equals to f of x comma y comma z plus lambda into pi of x comma y comma z. This is a Lagrange's function. First we have to form the Lagrange's function from the given information, where lambda is called as Lagrange multiplier, which is determined by the following conditions. So in the step 2 we obtain the equations dou f by dou x is equals to 0. It means we differentiate this whole function with respect to x and we equate to 0. So that means when we are differentiating this function with respect to x, it means the inside this function is also differentiated with respect to x, and at the same time second term is also differentiated with respect to x. So that comes as dou f by dou x plus lambda into dou pi by dou x is equals to 0. So this is as a second equation. Then we also differentiate this function with respect to y, that is dou f by dou y is equals to 0. That comes as dou f by dou y plus lambda into dou pi by dou y is equals to 0. And we take that as a third equation. Then at last we also differentiate the function with respect to z, that is dou f by dou z equals to 0, and dou f by dou z plus lambda into dou pi by dou z equals to 0. Let it be as a fourth equation. So in this way we differentiate the function with respect to x, y, and z, and then after we equate to 0. This comes in the second step. Finally, in the third step, we solve the equations 1, 2, and 3 and 4. Then we get the values of x, y, z. Then the point x comma y comma z be the extremum of the function f of x comma y comma z. Then that will be the maximum or minimum point. It depends on the given question of the given function f of x comma y comma z. So we have to solve these 4 equations and we will get the values of x, y, and z. We shall see the problem here. First problem: find the minimum value of x square plus y square plus z square given x plus y plus z equals to 3a. The given, this is a condition and this is a function. So we had to find out the minimum value of the given function by using this condition x plus y plus z equals to 3a. So let f of x comma y comma z be x square plus y square plus z square. So it means this is a function, and then pi of x comma y comma z equals to x plus y plus z equals to 3a, and when we are equating this to 0, so when I send this 3a to left hand side, it becomes minus 3a and that equals to 0. So we are taking it as a equation number 1. Then the condition comes as Lagrange's multipliers, that is f is equals to small f plus lambda into pi. Then f is equals to, this is a function with x, y, z variables plus lambda into pi of x comma y comma z. Then here this function comes as x square plus y square plus z square plus lambda into pi of x comma y comma z is x plus y plus z minus 3a. Now we have to differentiate this function with respect to x, y, and z. So at first we are differentiating with respect to x. that is dou f by dou x is equals to dou f by dou x plus lambda into dou phi by dou x is equals to 0. Then dou f by dou x is equals to, now we are differentiating x square plus y square plus z square function with respect to x plus lambda into, because as this lambda is a Lagrange multiplier which is a scalar one, so we are not differentiating it, and lambda into differentiating this function, that is dou by dou x of x plus y plus z minus 3a, and we are equating it to 0. Then x square differentiation with respect to x, 2x, and this the differentiation of y square and z square with respect to x becomes 0, plus lambda of x differentiation with respect to x is, and this lambda into x, that is and x differentiation with respect to x is 1, and that 1 is multiplied with lambda, that comes as lambda. Then here the differentiation becomes 0 and we are equating it to 0. Then 2x plus lambda is equals to 0. So from this we have to write the lambda value, that lambda is equals to, send this 2x to the right hand side, it becomes minus 2x, and let it be as equation number 2. Lambda is equals to minus 2x. Then we have to differentiate the function f with respect to y, and that comes as dou f by dou y is equals to dou by dou y of x square plus y square plus z square plus lambda into dou by dou y of x plus y plus z minus 3a is equal to 0. Now y square differentiation with respect to y is 2y, and from here lambda into y differentiation with respect to y is lambda. So 2y plus lambda is equal to 0, and then lambda is equals to minus 2y. So from this also we got the lambda value, and we are taking that as equation number 3. Again we are differentiating with function f with respect to z, that is dou f by dou x z equals to dou by dou x of the function x square plus y square plus z square plus lambda into dou by dou z of x plus y plus z minus 3a, and we are equating it to 0. Now z square differentiation with respect to z is 2z, and then lambda z differentiation with respect to z is lambda. Then from this 2z plus lambda is equals to 0, and lambda is equals to minus 2z. So let this be as equation number 4. Now we got the equations 1, 2, 3 and 4. From that solve the equations 2 and 3. So equation 2 was lambda is equals to minus 2x, and equation 3 was lambda is equals to minus 2y. So from those two equations we can write it as minus 2x is equals to minus 2y. So at both sides minus 2 gets cancelled, and at finally we get x is equals to y, and we are taking that as equation number 5. Then again we have to solve the equation 2 and equation 4. Equation 2 was lambda is equals to minus 2x, and equation 4 is lambda is equals to minus 2z. So from these two equations we can write it as minus 2x is equals to minus 2z, and from this condition we get x is equals to z. Let it be as equation number 6. Now substitute y is equals to z and z is equals to x in equation 1. So we got z as x and y also as z. So we have to substitute this both in equation 1. When we substitute in equation 1, pi of x comma y comma z equals minus 3a is equals to 0. We get x plus x minus 3a is equals to 0, and this comes as 3x minus 3a is equal to 0, and x is equals to a. So we got the value of x as a, and we know that y is equals to z and z is equals to x. So y also a and z is also a. So from those two conditions, from x is equals to y and x is equals to z, we can also equate y is equals to z. So from this we get y value as a and z value also as a. So the point x comma y comma z is equals to a comma a comma a. This is a point, and this is a extremum point of the function f of x comma y comma z. So we know that it's extremum point. That means it is either maximum or minimum, but in question it's given as minimum. So at finally we are writing a conclusion step, that is therefore the minimum value of f of a comma a is equals to x square plus y square plus z square, and that equals to a square plus a square plus a square, that comes as 3a square. So this is the extremum value and the extremum point is a comma a comma a. So we can even call it as minimum value and this is a minimum point. Here we shall see another problem. Find the volume of the largest rectangular parallelepiped that can be inscribed in ellipsoid. X square by a square plus y square by b square plus z square by c square is equals to 1. So this is the ellipsoid. If ellipse, we have only two dimensions x and y, and ellipsoid is a 3 dimension, so we have here 3 variables x, y and z. So we have to find out the largest rectangular parallelepiped that is inscribed in the ellipsoid. We are taking the dimensions of the rectangular parallelepiped as 2x, 2y and 2z. So let 2x, 2y, 2z be the dimensions of the rectangular parallelepiped, and the volume of the pipe comes as the multiplication of these three dimensions. That is, volume is equals to 2x into 2y, 2z. Then this is a function. So this volume is a function and this comes as the pi. Then f is equals to 2x into 2y into 2z, and that comes as 8 into x in 8xyz. Then pi is equals to x square by a square plus y square by b square plus z square by c square, and when we send this one to the left hand side, it get it as -1 and that equals to 0. So this let it be as equation number 1. Then we have the Lagrange's multiplier as f is equals to f plus lambda into phi. Then we write f is equals to f of x comma y comma z plus lambda into pi of x comma y comma z, and then f is equals to this function, we got it as x in 8xyz plus lambda into the pi, and that equals to 0. Then we have to differentiate this function with respect to x, y and z. So at first we are differentiating with respect to x, that is dou f by dou x is equals to dou f by dou x plus lambda into dou pi by dou x is equals to 0. Now we have to differentiate this function with respect to x, 8xyz differentiating with respect to x, and plus lambda into dou by dou x of x square by a square plus y square by b square plus z square by c square minus 1 is equal to 0. Then 8xyz differentiating with respect to x, we get it as 8yz plus from this x square differentiation is 2x by a square is a constant and into lambda equals to 0. So from this, lambda of 2x by a square is equals to, send this 8yz to the right hand side, we get it as minus 8yz. Then lambda is equals to, send this 2x by a square to the right hand side, then it comes as a square by 2x. So 2 4s are 8 and that equals to minus 4a square yz by x, and let it be as equation number 2. Then similarly we are differentiating f with respect to y. Dou f by dou y is equals to dou f by dou y plus lambda of dou pi by dou y is equals to 0. And then we write the functions here. Differentiation of 8xyz with respect to y comes as 8xz plus lambda of y square differentiation with respect to y is 2y and by b square, that equals to 0. Then lambda of 2y by b square is equals to, send this 8xz to the right hand side, we get minus 8xz, and lambda is equals to, send this 2y by b square to the right hand side, we get b square by 2y, and 2 4s are 8, we get it as minus 4b square xz by y, and let it be as equation number 3. And also we are differentiating the function with respect to z, that is dou f by dou z equals to dou f by dou z plus lambda of dou pi by dou z equals to 0. And then we write the functions f and pi here. Then differentiation of 8xyz with respect to z, it comes as 8xy plus lambda into z square differentiation is 2z by c square is a constant into lambda, and that equals to 0. Then lambda of 2z by c square is equals to, send this 8xy to the right hand side, we get it as minus 8xy, and then lambda is equals to, send this 2z by c square to the right hand side, we get c square by 2z. Then 2 4s are 8, and it finally lambda value comes as minus 4c square xy by z, and let it be as equation number 4. Now from equations 2 and 3, so we have to solve the equation 2 and 3, that is x is equals to this value and the y is equals to this minus 4b square xz by y. From this both the lambda values are same, so we get these values and we equate them. We get here minus 4 and minus 4 gets cancelled in the numerator, and z also gets cancelled. Then it comes as a square y by x is equals to b square x by y. Then from here cross multiplication, a square y square is equals to b square x square. Then here y square is equals to b square x square by, send this to the right hand side, we get divided by a square, and then it finally y is equals to under the root of bx whole square by a square, and that equals to square and roots get cancelled, and finally y value we get it as bx by a. Then from here y is equals to bx by a, let it be as equation number 5. Then from equations 2 and 4 we get this relation, that is minus 4a square yz by x and equals to minus 4c square xy by z. So minus 4 gets cancelled on both the sides and y also gets cancelled. The remaining is a square z by x is equals to c square x by z. Then by cross multiplication we get it as a square z square is equals to c square x square. Then z square is equals to c square x square by a square. Then send this square to the right hand side, you get it as root of cx whole square by a square, and square and root gets cancelled, we get it as cx by a. So therefore z value is cx by a, and let it be as equation number 6. So from equation 5 and equation 6, substitute these two equations in equation number 5. We get x square by a square plus bx by a whole square, this is a y value, and divided by b square plus cx by a, which is a z value whole square, divided by c square minus 1 is equals to 0. Then from here x square by a square plus b square a square by a square into 1 by b square plus c square x square by a square into 1 by c square minus 1 is equal to 0. Then b square gets cancelled, and also c square gets cancelled here. Then finally we get a square x square by a square plus x square by a square plus x square by a square minus 1 is equals to 0. So by these three terms we get 3x square by a square minus 1 equals to 0. Then from here cross multiply here, here a square into 1, that is a square, that is 3x square minus a square, and send this denominator a square to the right hand side, and it multiplies with 0, it becomes 0. Then 3x square minus a square is equals to 0. Send this minus a square to the right hand side, we get plus a square, that is 3x square is equals to a square, and here a square is equals to a square, and here it's multiplying with x square, and send this 3 to the right hand side, it divides, that is a square, x square is equals to a square by 3. So when you send this square to the right hand side, it becomes root, then x is equals to root of a square is a and divided by root 3. So this is the value of x, that is a by root 3. Now substitute the x value in equation number 5, that is y is equals to bx by a. So when you substitute here b by a into a by root 3, a gets cancelled and we get it as b by root 3. So the y value is b by root 3. Then when you substitute x value in equation number 6, that is z is equals to cx by a, we'll get the z value, that is c by a into a by root 3, a gets cancelled and we get it as c by root 3. So therefore z is equals to c by root 3, this is z value. Then we had to find out the volume of the given rectangular parallelepiped, that is volume is equals to 8xyz. So 8 into x is a by root 3 and y is b by root 3 and z is c by root 3. So when you do this, you get 8 into 8abc divided by root 3 into root 3 is 3, and that 3 into root 3 is 3 root 3. So therefore, volume of the given rectangular parallelepiped is 8 ABC by 3 root 3.